Great. So let's start. This session, we are going to cover the 12-factor app. Does anyone know about 12-factor apps? Could you please raise the hands? Great. So something interesting for you. Expectations, we can skip, and we already know each other. So some agenda, what we're going to cover. What is 12-factor app? It is a methodology for building modern, scalable, and maintainable software. We will cover the most important factors, not all 12. Other factors you can search by yourself. I will share you QR code. And we'll start from why does it matter? So it is really important, and 12-factor app helps you to build a scalable application. It helps you to simplify collaboration and simplifies deployment. In the previous section, we talked about environment variables, and this is one of the most important factors in 12-factor app. So we should use environment variables to configure your applications and to store different secrets. You shouldn't store it in your code and under source control. So you are moving it outside of your application code. This is an example of simplest environment file with environment variables, where we defined profile, DB URL, user password, and, for example, hook secret, some secrets information to use in your application. So after you run your application, these environment variables bind to your runtime, and you can use it in your application. So also your application should be stateless. You should not use any state, and you shouldn't store any information in memory or local storage, because there is some cases when you can do this, for example, different caching and so on. But for example, user sessions or different information you would like permanently save, you shouldn't store in RAM, for example. Also, it allows horizontal scaling, and with horizontal scaling, you improve the reliability of your application. For example, you have a client which uses your application. So you have 3 instances of your backend. And you decided by design to store client sessions in memory, not in centralized storage. So the load balancer splits traffic among these instances, and happy clients can use your website if his requests go to instance 1 or instance 2, because these instances know about this client, they have the client session. But suddenly the next request goes to instance 3, and instance 3 doesn't know about this client. So clients should pass authentication process again, and this is inconvenience, and this is bad user experience. So this is the bad case, and you shouldn't do like this. You shouldn't store like client sessions in memory. Concurrency. So in concurrency, you can run multiple tasks or process simultaneously. So usually you have like service A, and you up 3 or more instances of the same service. And it should be small, lightweight processes that can handle a load and process user requests. Disposability. Because your process is lightweight, should be lightweight and small, it allows rapid scaling and recovery. So your applications should start and stop really quickly, minimizing downtime. For example, something goes wrong with your one of the instances of your application, or Kubernetes cluster decided to rebalance resources between your applications and decided to kill one of it. So to hold the load to your application, you should start new instance as soon as possible. And if this process takes a lot of time, you can lose client traffic and it will be downtime because other two instances, for example, can't handle such load. So to implement this, you can use shutdown signals and shut down your services gracefully. So you handle SIG-term signals from different resource manager systems like Kubernetes, and you stop all your processes, for example, you close all your connections, utilize your resources in your app, and stop your server. Also, you can use health checks to detect and restart unhealthy processes. So if something goes wrong with your application, you using health checks, you can decide to kill this application and start new one, or maybe scale your application and up more instances in parallel. And you should avoid long-lived processes because in a cloud environment, you share all your resources, and if one of your processes holds resources really strong, the system can't kill it in gracefully way. So if you process like 5 minutes long and so on, after a couple of tries, Kubernetes can kill your process, and you can lose all your state and all data you processed during this long life process. And environment parity. Environment variables helps us to implement this factor. So you should keep development, staging, or for example, demo environments and production environments as similar as possible. You have an application, and this application could be configured for test environment using test variables. So if we return back here, everything will be the same. All your source code is the same and should be the same. But you would like to connect to test database, or you would like to change the profile or something else. So you would like to connect to a test environment, to connect your application to a test environment somehow. So you change for test environment, this environment file will be different, and the connection string will be different. For production environment, you should use, for example, profile production, and DB URL will be Postgres port and maybe production database, and obviously username password will be different. So another factor is logs. Logs are extremely important to track what's happening in our application. So popular frameworks will have popular frameworks has logs by default, like simple logs that can show you HTTP requests, in responses, and so on. But also you can use custom logs and track different business processes. For example, I entered this function, or I processed such number of requests, and so on. You can add as much logs as you want, but you should balance between important logs and just useless logs, not to trash your log system. So there are two streaming logs stacks. It's like a ELK stack. It is Elasticsearch, Kibana, and Logstash, and AWS tools like CloudWatch. Usually, I'm using Elasticsearch, Kibana, and Logstash for searching and for searching logs in my application. So that's it. Admin processes. If you're developing your application, there will be a lot of different admin processes, such database migrations. You would like to backup your database also, or run manual scripts, and it should be done in isolated processes. Migrations you can automate using cron technology, and all these processes should be run in the same environment as the app. So more about migrations, like usually you have your main application, main source code, and when you making task, extend your application, for example, adding new tables, or maybe changing indexes in your database, maybe adding some columns to a database tables. You would like to run migration that helps you to automate all this stuff and all these processes. Usually, these migrations can be done in, for example, separate pipeline. You are running all these migrations, and after this, you're running your application with a fresh and new database schema. So here you can scan QR codes and look through other factors. We covered the most important ones. And so the core principles, it is environment independence, stateless processes, consistency across environments, and that's it, I guess. So any questions about 12-factor app? No questions, right? Okay, 3, 2, 1. Oh, yeah. Elasticsearch. Elasticsearch, ELK stack, yeah. So actually, when you stream your application logs, there is technology that could help to scrap these logs from your environment and collect it in cloud databases, so you could return it anytime. Also, these logs are indexed, so you can fast search for any data in these logs and find different errors, bugs, or just any useful information there. Okay. Yeah.
This standard 12 factors is available in modern standard for any application. It doesn't matter what type of application.
Yeah.
Or only backend or
it's more about backend application. Yeah.
I experienced it. Concept.
Mm-hmm.
For managing and payments.
Mm-hmm.
Showing all the project folder.
Mm-hmm.
But I don't want I didn't want to work on how to do application. I think for best practice among all the developers, that would be the way to implement this kind of assets and factors. For example, every application database, server, using some kind of Kubernetes.
You would like to know other factors? Okay.
Other factors will
12 is I guess it's the most important one. I guess you're talking about best practices. Some of these factors could be used for front end, sure, but right now, so I can't cover like best practices of it is main principles to build backend software. Yeah, and also best practices, but not all. Yeah. Okay, I guess we can finish with this presentation, and it is you will have more time maybe for setting up your servers if someone haven't done. So let's. Great. Stop sharing.